Welcome to Intermediate Algebra, Unit 5, Lesson 1, using the rules of exponents. After finishing this lesson, you should be able to apply the rules of exponents to simplify expressions with integer exponents, understand the meaning of a negative exponent, know that a quantity raised to the 0 power is equal to 1, and you should be able to evaluate, in other words, find a number for numerical expressions with exponents using a calculator. So what is an exponent? If you haven't seen them in a while, you may not recognize it. You may recognize it, but not remember what it means. So an exponent is written as what we call a superscript. So in this case, when we say 2 to the third power, that is a superscript. You can see this x plus 5 has a superscript of a 2. That would be an exponent of 2 on the x plus 5 that's grouped together. 3 to the negative 2, the exponent is negative 2. X to the 5th, the exponent is 5. So let's start with looking at the 2 cubed. What does this mean? The big mistake students make is they think it means multiplication. It does involve multiplication, but you're not multiplying the 2 times the 3. So the 3 above the 2 tells you how many times to write the number 2. So this tells me I am going to write the number 2 3 times and multiply them together. So when I do that, I don't get 6, which is 2 times 3. I get 8. So you must do this operation correctly. So here are ways of writing out an exponent. An exponent is a shorthand way of writing repeated multiplication. So for this one here, notice the x plus 5 is grouped together, so you write the x plus 5 twice because the exponent goes with the whole set of parentheses. And x to the 5th, you write this x out 5 times. It's much easier to write x to the 5th. So you're going to start encountering some negative exponents. And the idea that 2 to the third is a 2 written down 3 times multiplied, you can understand that idea, but what does the 2 to the negative 3 mean? It does not put a negative sign in front of your answer. That is not what it does. Don't do that. You have to pay attention to this explanation. It has to do with fractions. So 2 to the negative 3 is another way of writing 1 divided by 2 to the positive 3. So let's look at 3 to the negative 2. The negative exponent will change the 3's position in a fraction and become a positive exponent. So if you want to make that exponent positive, which we'll learn later is completely simplified, to be completely simplified, you have to have positive exponents. If you want to make that, turn that around so you have the exponent as positive, you have to change the position in the fraction. Well, you say, what fraction? It's 3 to the negative 2. Well, remember, you could write a 1 here. And the other thing I want you to remember is that there's a 1 written here that isn't written. There's a 1 there that's not written. It's implied. 1 times anything doesn't change the value, just the same as dividing by 1 doesn't change the value, so we don't write them. So when you change the position of the 3 in the fraction, what we mean is that 1 stays there, but the negative 2 goes with the 3, so you're going to write it multiplied by the 1 down here instead, but you're going to change the sign of the exponent to be positive. So you're going to leave the 1 up there, and we don't usually write the 1 underneath, so we'll just take that out. And we don't need the times sign if we don't have the 1. So that's where the rest of this explanation comes from. You must be careful to only move the quantity that actually goes with the exponent. When you have something grouped in parentheses and then the exponent, the whole group moves, as in here. But here, this is 3 times x to the negative 4. The negative 4 only goes with the x. It's not grouped with the 3. So you must leave the 3 in the top and just move the x and now make the exponent positive. So those are two different things. The mistake students mostly make with this one is I will see students do 1 over 3 x to the 4th, which is not true. The 3 has to stay up here. Okay? Just be careful of that. Now, exponents on fractions. When an exponent is on a fraction, you put the exponent on the top and on the bottom. Well, why is that? I have 2 to the third written down 4 times, according to this exponent of a 4 I see on my fraction. And I multiply. Well, when we multiply fractions, and those are 2's up top there, we just multiply straight across. The top straight across the bottom and make a new fraction out of the results. So that is 4 2's multiplied together, and that is 4 3's multiplied together. So that's how I would get that longhand. But knowing that, you could take this shortcut. These two mean the same thing. When you have a fraction raised to an exponent, you raise the top to the exponent and you raise the bottom to the exponent. So how does this work with a negative exponent? It goes with the top and the bottom, as you can see right here. I'm trying to pick up my pen here and it's giving me a hard time. So that's the rule I just showed you. But then remember, negative exponents, if I went to positive, I change position in the fraction. So I move the 2 to the bottom, make it a positive 4, move the 3 to the top. And then I end up with this. Well, if you look at the relationship between what we started with and what we ended with, the fraction at the end is simply the fraction at the beginning flipped. So if I had the fraction 3/5 raised to the negative 6th power, the first step I would do was write that as 5/3 to the positive 6th power. You switch the order of the fraction to make the exponent positive and now proceed. That's what that means. You can just flip the fraction and make the exponent positive. That will switch the order of where things appear on the top and bottom. So now what about simplifying multiple expressions? Well, what I'm about to tell you only applies if the base is the same. We call the 2 the base and the 3 is the exponent of this. Here the 2 is the base and the 4 is the exponent. If I had 2 to the 3rd times 3 to the 4th, I could not simplify that. That's as simplified as it gets unless you just want to convert it to a number, but you cannot write that using exponents in any form simpler than that because the bases are not the same. So what I'm about to say here only applies to when you have the same bases. So if we write out 2 cubed times 2 to the 4th the long way, there's 3 2's there, 4 2's there, and I multiplied those two things together, I end up with 7 2's. Shortcut for writing this is 2 to the 7th. It's not coincidental that a 7 could have been gotten by doing 2 to the 3 plus 4. I can add the 2 exponents when the base is written twice. That is the shortcut to simplifying those. So in the base, you have the same base, you can add the exponents if they are multiplied. Doesn't work if they're added, doesn't work if they're subtracted. So the next thing we're going to encounter looks similar. Division. So if multiplication is addition of exponents, notice the bases of my 2 to the 3rd, 2 to the 4th, bases of 2 in both. Division can be done using subtraction. So I subtract, the top exponent is a 3, and I subtract the bottom exponent of 4, and that leaves me with a 2 to the negative 1 on top. Well, I can rewrite that as 1 over 2 to the positive 1. I don't usually write the positive 1 exponent, though. So I did top minus bottom and left the result on the top. I could have done this. I could have left the 1 up there and done 2 to the 4 minus 3. So if I do bottom exponent minus top exponent, I leave the result on the bottom. And that also would give me 1/2. So division, you're subtracting. The number you start subtracting with, if it's the exponent on the top, you leave the result on the top. If it's the exponent on the bottom, you leave the result on the bottom. Students get confused when we start to involve negative exponents in this. I would suggest that maybe you convert all your exponents to a position where they are positive and then proceed with simplification. But if you had a negative exponent on the bottom, you would do the top exponent minus a negative, you would end up adding the exponents. For instance, if this were 2 cubed over 2 to the negative 4 instead, and I start by top exponent minus the bottom exponent, you would need parentheses around that negative 4. You're subtracting a negative 4, which is adding. You would get 2 to the 7th in that case. So this example is different than the one we had where we had 2 to the third times 2 to the fourth. You're thinking it looks really similar. I have a 2 to the third and a 4. But what you have to notice, and you must observe your problem first before you can decide which rules apply. I only have the base 2 written once in this new problem, and the old problem was base to an exponent times base to an exponent. This is base to an exponent, whole thing raised to another exponent. So what this means, if we write out 2 to the third raised to the fourth power, it's 2 to the third multiplied itself 4 times. And each of those 2 to the thirds gives me 3 2's multiplied together. If I count all those up, I get 2 to the 12th. I get 12 2's there. The rule that would allow you to do this quicker is that when you have an expression with an exponent raised to an exponent, you can multiply the exponents. So this would come out the same, that's 2 to the 12th, if I had 2 to the 4th cubed as if I have 2 cubed to the 4th. So what happens when an exponent is 0? If the exponent on an expression is 0, then the expression is simplified to be a 1. You can use the rules of dividing exponents to figure this out, and that's what I'm going to show you here. So a long time ago when you learned to divide, you learned that any quantity divided by itself, as long as quantity wasn't 0, is equal to 1. So you learned that 6 divided by 6, for instance, is 1. Number divided by itself is 1. Well, variables divided by themselves are also 1 as long as the variable's value cannot be 0. So x squared divided by itself gives me a 1. That is true. So any other way I come up with evaluating x squared over x squared, it has to result in a 1. So let's take one of the rules of exponents we just looked at. Now I have x squared over x squared. I'm going to look at it as like bases raised to an exponent. I have an x base on top, an x base on the bottom. I do the top exponent minus the bottom and leave it on the top. And that gives me x to the 0 over 1, which is just x to the 0. On the last slide, though, I showed you that x squared over x squared is 1. So if I start with x squared over x squared, I have to end up with 1. That means x to the 0 must also be 1. So the rule you come out with is when you raise a quantity to the 0 power, you get 1. So you're going to be told simplify in your instructions, and that can be a frightening word in mathematics because you never really feel like you're sure when you're done. So let me clarify this. To be considered simplified, an exponential expression has to have all positive exponents and all factors with like bases combined. So for example, if I had 2x to the 5th y to the negative 2 over y to the 4th, my first step might be 2x to the 5th, and I'm going to move that y to the negative 2 to the bottom and make it a positive 2, and they'll be multiplied. I'm not done yet because I have to combine these. I get 2x to the 5th over y to the 6th. So that's what simplify means. Okay? So you can't leave the negative exponent, and you can't leave two bases multiplied together. You couldn't leave y to the 4th squared. You would have to simplify that. So when your expressions have just numbers, you can simplify to a number using your calculator. So your calculator, depending on the type of calculator, either has a key that looks like, I don't know, we called that a caret when I was a kid. I don't know what you call it now. But that means I'm going to make this my exponent. Or you have a key that looks like this. And some calculators will vary, so you need to try this problem on your calculator. Find whichever key applies and make sure you can get 81. So I want you to find 3 to the 4th in your calculator using whatever keys you have. I want to make sure you can find the keys and get 81. If you cannot, you need to bring your calculator to me or to the tutoring center or to any math professor, honestly, and get instructions on how to use exponents on your calculator. So make sure, or you can, if you email me the make and model of your calculator you're using, I may be able to email you back some more specific instructions, but make sure you can do this problem. 3 to the 4th. If you see that, make sure you know how to get 81 from your calculator. So those are all the objectives I wanted to cover. Now let's do some examples of each. I want to simplify 2 to the negative fourth. Well, this is our negative exponent 1. And I'm going to move that to the bottom of the fraction. That'll leave a 1 at the top, not a 0, it leaves a 1, and that becomes 1 over 2 to the fourth. And possibly you would do 1 over 2 to the fourth in the calculator and get 16. So you get 1/16. Let's move on to our next example. Now, this example, what I see is I have two things multiplied together, and they each exponential expressions with a base of x. I add the exponents because the base is written twice and they're multiplied. This is one with a fraction to a negative exponent. I flip the fraction and make the exponent positive, and we don't generally write that in one, we leave it as implied, so you get y over x is the simplification there. Y cubed squared. The base is y on this exponential function inside the exponential expression inside the parentheses, and it's raised to the second power. So this is the rule where I multiply. 3 times 2 is y to the 6th, and if you write that out longhand, you can confirm that. Now this is division. I could do this a couple of ways. Oops, I went to the next example, sorry. I could do this a couple of ways. If I have all positive exponents to start with, I tend to go where the bigger number is and then subtract. So the bigger number's on the bottom, so I'm going to do the bottom minus the top and get 1 over x to the 5th. If you did top minus bottom, you would have got this, and then you got x to the negative 5, but that's not simplified because your exponent is negative. So then you would have to write 1 over x to the 5th, but it comes out the same either way. Example 6. You have to remember what I said about what does the exponent go with. This exponent only touches the negative 5. So the 4 stays on top of the fraction. Get that. If I had had 4y to the, I'm not writing correctly, sorry. If I'd had parentheses 4y to the negative 5, then I would have had 1 over 4y in parentheses. You have to keep the parentheses. The positive 5, the negative 5 is attached to the 4 because of the parentheses. You have to keep the 4 attached to the positive 5 in the bottom by using parentheses also. In this one, okay, I have two variables, but I see I have x's multiplied together here. So that becomes x to the 2 plus 3. That's the rule for combining those, so I get x to the 5th, y to the 5th. I have something to the 0 power. As a matter of fact, I have x to the 5th, y to the 5th to the 0 power. It doesn't matter. The last thing I do is raise it to the 0 power. I get a 1. So here are some for you to try. Shut the video, stop the video, try these problems, and come back and check your answers. You're back. Here are the answers. If you had trouble getting these, please bring these to the tutoring lab, email me, or find your mistake. If you can do that, that's actually even better. You'll remember it better that way. And you need to not let this go if you're not understanding this. That's it for this edition of Math Teacher to Go, and I'll see you next time.